Hello, everyone. Welcome back. Today, we're going to talk about finding the shortest distance from a point to a line. Now, this one is going to this is going to be our last little bit of this unit, and it's also probably the hardest, I think, for a lot of people, just because it uses so many different things. But first, I want to talk about not just this question, but in general, how would we find the shortest distance from a point to a line, right? Because there could be many distances, but we want the shortest one. So let's say I'm just going to draw some random line and some random point. Well, how would you go about drawing this point to this line if I said do it in the shortest distance you possibly can to get to this line? You probably wouldn't draw something like this, right? This would clearly be a very long distance, right? What you would do instead is probably draw something more like this. Oh, oops. Something more like this, because that's clearly a much shorter distance, right? In fact, the shortest distance is where we don't have any non 90-degree angles. The shortest distance is the distance where we're going to intersect at 90 degrees. So that's a clue right there as to one of the things we might have to do in order to figure out to figure this out, right? But there we have it. There we go. We need to take the point and we need to find out where it intersects with the line, right? The shortest distance, where it intersects perpendicularly with the line to get that shortest distance. So, what do we need to do for that? Well, the first thing you probably can imagine is, well, we need to find out this the equation of this new line, the equation of this perpendicular, not necessarily bisector this time, right? Because the line is infinite now, but the where these intersect in a perpendicular way. So we already have that the slope of our original line is going to be 3, right? So our new slope of our new line, is going to be equal to negative 1/3. So there we go. We already know that. And we also know we also know we also know that a point on this line is 6, 7. So we can also find the y-intercept of this line, right? We can also do that. So let's do that. Oh, y equals negative 1/3 x plus b. And let's find the y-intercept by recognizing that a point on this new line that I made is 6, 7. So b equals 9. So therefore, the equation of our new line is y equals negative 1/3 x plus 9. Okay, so now in order to find the new point, we need to figure out which point do these two lines intersect. And this is actually material we learned last unit when we talked about substitution and elimination. So I'm going to call this equation 1 the original equation we have, and this equation 2. And I'm going to sub 1 into equation 2 and say negative 1/3 x plus 9 equals 3x plus 8. So therefore we have over here 10 over 3x equals to 1. And then we would have x equals 3/10. Okay, so x is equal to 3/10. So what is y then? Well, y would equal to 3 times 3 over 10 plus 8. So therefore, y is going to be 9 over 10 plus 8. Well, 8 is the same as 80 over 10. So y is equal to 89 over 10, or 8.9. Awesome. So there we go. So there's our point, right? So the point where they intersect is 3 over 10, 89 over 10, right? That's this point here where they intersect. We found out the point. And now they want to know, what's the distance between this new point that we found and our original point. So now let's do that. Let's find that the distance is equal to the root of y2 minus y1 squared plus, oh, sorry, this looks like y squared. It should be y2, my apologies. X1, or no, sorry, x2 minus x1 squared, although we are about to square these, so it doesn't actually matter. And we want to find the distance between that new point we just found, which is where those lines intersect perpendicularly, and our original point. So let's fill in those blanks here. So that's going to be 8.9 minus 7 squared, and 0.3 minus 6 squared. Okay, so that's going to be the square root of, let's see, 1.9 plus negative 5.7 squared. Awesome. 3.61 is 5.7 is 32.49. So overall 36 root 36.1. So this is just going to be slightly more than 6. So therefore the shortest distance is the square root of 36.1. So about 6, a little more than 6 though, as it turns out. But very, very close to 6. So there we go. So that might seem like a lot of steps, and you know what? It is a lot of steps. But as long as you understand why we're doing each step we're doing, it's not as bad, right? Because we first have to recognize that to find the shortest distance, we need to figure out what's perpendicular. And to do that, we need to take the negative reciprocal slope. Then we need to find the rest of the equation of a line by plugging in that point. Then we need to find, okay, where does the new line and the original line, what point do they intersect at, right? What is that intersection point? And then we can say, okay, so what's that distance between that point, right, the closest point, and the original point? And then we finally, at long last, have our answer there. So there we go. All right, well, that's it for today. Good work today, everyone, and I will see you next class in Unit 3. Bye, everyone.